Hi, this is a walkthrough for HI, which stands for Hacker AI. It's a REPL designed for hackers using LLMs. Now in this video, we'll go through what makes it different from other chatbot interfaces. But first, the basics. To install HI, go to GitHub and copy and paste the install command. This downloads a single 8 meg compressed binary. Now it's written in Rust, so I do have to mention it's written in Rust. But that also means it's low overhead, launches in 30 milliseconds on my machine, and is cross-compiled for everywhere. So you can use it on your machine, your containers, your servers, or even your Raspberry Pis. Now to start, just run HI, and now you can say hi, just like every other chatbot interface. Now the magic in HI lives in these front/ commands, and we'll cover those by related groups in the later sections. So to start, a few of my favorite ergonomic features. First, I can quickly start and have many conversations just by opening new terminal tabs. It's just really quick and easy compared to browser-based tabs, especially since I ask LLMs lots of random questions. Second, HI supports Markdown and code syntax highlighting. So I can ask it to, for example, write bubble sort in many languages, and you'll see each of these languages has syntax highlighted. I can also interrupt the AI using Control-C. The AI still sees what was printed and knows it was interrupted. So this is just like a very natural REPL interface. Starting a new conversation is a matter of a simple /new or just /n for short. All major AIs are supported, whether it's from OpenAI, Anthropic, Google, or DeepSeek, as well as Ollama for local AI usage, reasoning and non-reasoning models, vision and function calls. Now to switch AIs, you just have to type /AI, there's tab completion, we can switch to sonnet thinking, and we can say hi. So you can even switch within a conversation, which I sometimes do to double check work, and you can also use it for, say, cost optimization. Now on the bottom right, there are a few things here. First is Ken, that's my HI account username. It's completely optional, but having a user account lets you share tasks and assets with others publicly. Demo is the current working directory. That's important when HI interfaces with your local file system for tool usage. This is the current token count in the conversation. You can also type /cost to see how much this conversation has cost so far and how much each incremental message will cost. This is the AI model name, and lastly is the timestamp. You can also use HI to start HI in incognito mode. This means the conversation is not recorded, and you can specify a custom incognito AI model. In my case, I'm using Qwen3 running through Ollama, which means my data never leaves my machine, and it's truly fully incognito. All this can be configured through your hi.toml configuration file. It's in your .hi folder. This is a .new version, which is like a fresh copy to show you. So here you can specify a default AI model, a default incognito AI model, as well as the various API keys you need for each of the AI providers. First up is HI's Tools feature, which lets LLMs write and run programs on your machine. They're built on top of the function calling interface that many LLMs provide. So let's start with something basic. You can ask an LLM to do arithmetic with generally questionable results. So let's ask the LLM to compute 1, 2, 3, 4, 5, 6 times pi. Now let's ask the LLM to do the same but with Python. So !py. This tells the LLM to use the Python tool. 1, 2, 3, 4, 5, 6 times pi. Now the output's broken up into two sections. The first section is the program that the LLM wrote, and the gears indicate an execution occurred, and then here's the answer. And as you can see, it deviates ever so slightly from the guesstimate done earlier. All right, now let's use the Python tool to compute the distance from San Francisco to New York City. Now, if we look at the program here, it uses the GeoPy Python library, which unfortunately I don't have installed, and so this program actually errors. Now, what we can do is we can simply use exclamation. This will resubmit the exact same prompt to the AI, but this time it'll see that its previous program failed due to a lack of GeoPy. So let's see what happens. So this time around, the AI decides to avoid using GeoPy and instead uses the vanilla pre-installed math library available in Python. So that works. But say you really want to use the GeoPy library. What you can do is use exclamation with apostrophes, and between apostrophes you can use any program that takes standard input, and the LLM will figure out what to do. So we can use UV run with GeoPy. If you're not familiar with UV, it's like the new cool kid on the block. It's very well deserved actually, as a Python package manager that just kind of works. Let's do distance from NYC to SF. All right, and so we can see the answer differs ever so slightly, but now we use the GeoPy library. Now I can use exclamation, but with a slightly different prompt, so I'm not going to re-specify the UV tool, but I can say, hey, what's the distance from Tokyo to SF? Yep, and so it's able to use GeoPy via UV and come up with that answer. For the next demo, I'm going to go ahead and convert these images to PNGs. So exclamation is not actually a tool. That's simply executing a shell command. I know it's a bit confusing, but I just found it easier to remember that everything tool or shell based is just exclamations. Now we can use the exclamation sh, the shell tool, to convert JPEG to PNGs. All right, let's verify that they're there. They are indeed there. We can use /load to load the PNGs. We can see that there are 3, an apple with a white background, an apple on a table, and my son eating an apple. And we can ask the AI, which photo is most different from the others? And it says that the third photo, a baby eating apple, is most different, which is pretty reasonable. All right, now let's poke around Hi SQLite database that's stored in your home directory in the /.hi folder. And you can see there's a data.db file there. All right, this time we're going to enter tool mode for the shell, so the shell tool mode. Now anything I type will implicitly be asking the AI to use the shell tool. So let's ask it to list tables in SQLite DB. Okay, these are the tables. Now we can say describe account table. Cool. There's a user ID, username, token, logged in at, and active. So how about we show rows, but without the token column, because that would be sensitive information. And so here we are. These are all the accounts. Now I can use exclamation question mark, which actually forces the LLM to request approval from you before executing the tool. And so that's useful if I say want to do something destructive, like maybe delete Ken. And so that's the SQL statement it would use. So I want to execute it. No, I do not. So definitely something to use whenever you're running a potentially destructive command. All right, now there's another tool, the Hi tool. And what this Hi tool does is it actually asks the AI to write the REPL commands for you. So I can say exclamation Hi, load the Silk Road wiki. Who was the founder? So now the LLM knows to do 2 things. The first command is to load the URL of the Silk Road wiki, and the second is to prompt itself who was the founder of Silk Road, knowing that the Wikipedia information would now be inside the conversation. So 2 commands were pushed into the queue. The first command successfully loaded this Wikipedia article in Markdown format. That's the value of using load URL. It'll actually convert HTML to Markdown whenever possible, which greatly improves the token efficiency. And then it prompts itself. And as you can see here, it came up with the correct answer. You can actually go a step further and actually ask the AI to use the Hi tool recursively. So I can say, Hi, get a random number. Call yourself to read the result. If it's even, ask AI how large the sun is. If it's odd, ask AI how large the moon is. So we can see it chose to use Python to generate a random number, and then it reads the result. It decides that the result is in fact even for its own prompt, so it asks the AI or itself, how large is the sun? And as you can see, it successfully gets an answer. All right, last, there's something called AI-defined reusable functions. And this requires you to do exclamation FN and then -py because you want a Python function to be defined. We can say, hey, find the square root. This generates a new command, F0. And we can use F0 directly in the terminal, pass arguments into it, and now we can execute this function without going through an LLM whatsoever. But you can still use the hi tool and ask, what's the square root of pi? And the LLM is smart enough to know not to use, say, the Python tool or any other tool. It can actually just use the function we defined already and call it in order to get the answer. So this is really useful when you don't want the LLM to keep rewriting the same function over and over again for slightly different inputs, especially when they're really large functions. Instead, you can have the LLM write the function once, say to process a log file, and then you simply ask it to run that function across many files. Next up is Hi's tasks feature. I actually love tasks because it makes it easy for each of us to share what we're all doing with LLMs in a repeatable way. It's also transparent, so you can see how the LLM is being instructed, which is the opposite of the trend right now towards LLM wrapper apps. It's also just more powerful because it's not just a system prompt. A task has the full power of the REPL. It can load URLs, APIs, files, ask the human questions, cache responses, use tools, and more. So one task I made is a copy of a funny system prompt I found on Reddit called Absolute Mode. It removes all the fluff from the conversation with the AI. So you can execute it with /task, ken absolute mode. This enters task mode, and you can see it on the left of your REPL input. Now you can see every step you use to instruct the AI here. In this case, it's pretty simple. It's just one system prompt with text. And I love the last line, which is that model obsolescence by user self-sufficiency is the final outcome. So we can go ahead and chat with the AI now, configured this way. As you can see, it's not too friendly. And actually not friendly at all. Now, when you're in task mode, /new restarts the task from a blank slate rather than the entire conversation. So you can see the AI still operates with its instructions. To exit a task, you use Control-D, or you can use task end. All right, another task is Simon Willison's AI benchmark. Basically, you ask the AI to draw a pelican riding a bicycle in SVG, and you see what you get. The better the bicycle, the more intelligent we assume the AI is. So if we execute the task, we see that it wants to execute Cairo SVG, and what it's doing is determining if my system has Cairo SVG. Not there. Now it's going to check to see if convert is available. It is. As you can see, I have to confirm each of these potentially destructive steps, just in case the task is doing something nefarious. You can also run the task in trust mode to avoid all this. That's only recommended for tasks and users that you trust. Now it wants to use the shell tool to generate an SVG of a pelican riding a bicycle and converting it to PNG. So yes, that's what we want to do. This is the command the AI has generated, and we can confirm that we want it to be executed. So there it is. As a last step, you can actually have the AI describe this image, and we'll go ahead and do that. And it says it's a cartoon-style pelican sitting upright on a black bicycle with 2 large wheels. Yep, that sounds about right. Okay. So for the next task, it's important to know that every user on Hi is whoisable. So you can say /whoisken, and you'll see my name, my bio, as well as tasks that I've published. So if I want to change my name or bio, you can actually do that using a task. So /task Hi account update. And what you'll see here is it injects the API information so that the AI knows how to change this information. It also queries me for my API token. I've actually previously filled in my API token, and so it doesn't need it again because it's cached. It also knows to use asterisks because I marked it as a secret. So now I can ask it to maybe drop my last name from my name. Yeah, let's see if it did that correctly. As you can see, it did. I can say bring my last name back. So this is kind of a nice way to start having more of a conversational input into APIs and third-party services, whether on your machine or elsewhere. It kind of really changes the way we interact with services, which I like. Another task that I like, that I use, is called weather. And so this quickly just gives me a weather report for today and the next week, giving me the temperature, precipitation, and the forecast. So that executed very quickly. And the reason why is because a lot of the AI computation is already cached. In fact, I think all of it was. So it had previously asked me, what's my default city? I specified as Santa Clara, California. It's previously asked me about Celsius or Fahrenheit, and I specified it was Fahrenheit, that I prefer Fahrenheit. And then it also had already cached a AI-defined function, reusable function, to query the weather data from weather.gov. So it's all already here. So when I run the task, all it has to do is execute the F0 command. Okay, now if you want to make a task, well, something you can do first is you can go ahead and view tasks that exist by using task view, and that can give you an idea about how tasks are structured. But also, there's a task to help you make tasks, and this one's called Hi Quick Task. Okay. Great, so let's do something really easy. How about we make a task that gives me a Carl Sagan quote. So this is pretty simple, and you can see the task describes itself and then actually prompts itself or the AI to get the quote. So it looks about right. I'm going to use the SH tool so that the AI can write a file. So I'm going to say my username is Ken. That way it populates the username correctly here. Write task to, let's call it Sagan.toml. All right, there it is. I'm going to go ahead and quit this task, start over, and let's go ahead and try to run it. To run a task that's not published in the repository, but simply on your local file system, use // and then I can say Sagan.toml. All right, prompt above, and there it is. We've created a task with the help of a task that helps make tasks, and it's worked successfully. Okay, so there are many more. Well, not too many, but hopefully maybe you'll contribute some tasks out there. And to find them, you can simply use task search. You can use task view once again to view any that you find. And maybe I'll show you some that I have on my account, or maybe I'll talk through a couple just so we don't take too much time. But I have a task to play music. So music that I've stored as assets, which we haven't talked about, are synced to my machine and randomly played. I have another task for that lets you actually send me a message. I have another task that knows when my daughter was born and tells me exactly what I should play. It gives me some ideas for how I should play with her given her week in development. So these are all just various ideas. Assets are a key-value object store in the cloud that you and your LLM can use. It's designed with two purposes in mind. First, to be well integrated with the REPL, and second, to have a few AI-centric features that set it apart from just using something like S3. So here's how you can create an asset. You just use /asset or /a for short, and we'll say demo test. This creates an object with a pseudo file path-like key, just like you'd see in something like S3. We'll treat the contents like Markdown, give it a title, but we don't have to. So let's say hello world. Now to view an asset, you can use asset view, demo test, or alternatively, you can use assets in your shell executions using the special @ notation. So we can use cat and use demo test. In the background, it's actually copying the asset into a local temporary file. And we can actually even use shell output redirection to create a new asset. So we can say demo test, and let's go demo test 2. Using ls, not to be confused with ls on your file system, but there's like an asset ls, we can see that both assets now exist. So every asset is versioned, so if two different machines modify an asset simultaneously, the last to be saved will be spun out. So you can ask the AI to read and merge the two versions if you want. It's kind of an interesting take on conflict resolution, and does work for small, simple files. Now, the next command I want to talk about is /asset temp. And what this does is actually copies an asset to your machine temporarily, which allows an LLM to use it without having it in the conversation context. This is great if you're dealing with large data sets or non-Unicode input, non-Unicode assets, which just don't make sense to have in conversations. Let's go ahead and use asset temp, demo test. This information here is now available to the LLM, which can write programs using the temporary file paths. So let's go ahead and ask the AI to use the Python tool and print the asset. And so here the AI, the LLM, is aware of the temporary file path and is able to print the contents. Now, when you reset the conversation with /new, you'll see that the temp files are removed automatically. So if we do this, we'll see it exists. But now if we create a new conversation, the temporary file has been automatically removed. This means that asset temp is just a nice, convenient way to manage the lifecycle of temporary asset files on your machine. The next feature I want to talk about are public assets. So far the assets we've written are only accessible from my account. But you can make a public asset by using / followed by your username as the key prefix. So for example, we could use asset ken, maybe demo, this is public. So what's the advantage? It's a nice way to share, but also if you're publishing a task that uses data, a public asset is a great way to store that data because it won't matter who's running the task, which account they're using, if an account at all, the task will still be able to access it. As an example, let's look at the public or the official Hi account to see what assets are being shared. You can see it's mostly client blobs or CLI blobs, but also the changelog is there. So we can say, let's see, maybe we can get the, head of Hi changelog to see some of the most recent changes. There you go. All right, next feature to talk about is listening for changes. And for this, I'll actually use another instance of Hi. So let's go ahead and use asset listen demo test. This command won't return, or rather it blocks until demo test is modified. So we can go back here and modify demo test, change this to a exclamation mark, and now we'll see this command returns with a new URL of the latest data, along with other important data that an LLM may want to use. So this is great because it allows an AI to listen to changes and then act on those changes without using any kind of without using any polling sort of interface. As an example, I can use this task called task hi email asset updates. And I can ask it to listen to demo test. So now what this task does is that it'll send me an email anytime demo test is modified with the latest contents for demo test. So I can go ahead and use this. And there's a bit of stuff for it to do. It's not the most efficient, but what you'll see is that it eventually sends an email here. Oh, sorry, here. Cool. Okay. Now, this kind of presupposes knowledge of the /email command, so let me just show you this really quick. You can use this is the subject, this is the body, to send yourself email. And luckily, the LLM is also very aware of this command, so I can say email me an inspiring quote. And that's exactly what the LLM will do. So I use these features to implement a task called can mail. So you can actually use task can mail. And what this does is it will let you send me a message and will actually encrypt the message using my public key, which is stored as a public asset. So I believe I have it stored under, yeah, here we go, ls can public key, etc. And then I actually get notified of it via a task that I have that's constantly polling. All right, next feature is one called asset sync down. So this lets you sync down assets by prefix or folder prefix. And it's also efficient because if you've synced a file down before, then it won't sync it down again if the asset contents haven't actually changed. So I store some music as assets. So here we go. I have some Death Cab for Cutie songs. And I can actually use asset sync down music to my current directory. And you can see these all sync down smoothly. If I sync again, nothing is synced because they're all already there. You can check out the task called Ken Music Player to see how I built myself an LLM-powered music player in very, very few lines of tasks, very few steps. The last feature I want to talk about is metadata. Every asset can optionally have JSON metadata attached, and you can see this using asset md get. In our case, we can choose one of these songs that I've stored, and you'll see I've stored the album, the artist, the title, the track, as well as time-stamped lyrics. And so if you look at the music player task again, you'll see that as it plays the song, it'll actually print the lyrics at the correct timestamp using the metadata available. Earlier also, when we saw demo test, we saw that the title was extracted here. And the way that's done is it's actually automatically done for markdown documents. But basically, any asset can have a title, and that title will show up in the asset listing and asset search, which is a form of convenience for you. So we can see that definitively by asking for the asset metadata for demo test. And content type is another special cased metadata key. If set, links to asset generated by asset link are served with that content type set in the HTTP response. Now, I don't have time to cover everything, but asset search is also there. It lets you search based on content embeddings. And asset push, which is how things like my mailbox are implemented. Asset push basically creates a revision of an asset without marking the older revision as something that's deleted. It's effectively just creating a queue of changes, a queue of revisions that can build up, and that's how I implement messaging on top of Hi. So hopefully you see that the set of features built into assets help open up a kind of wide world of options for you and your LLM. That concludes the walkthrough. Hopefully you see ways to add Hi to your daily workflow. It isn't a dedicated coding agent, but it's one of my LLM daily drivers because of its abilities as a Swiss Army knife. I can ask questions, or I can enter tool mode and have it directly help me use programs, like stitching this video together with FFmpeg. I can write and run tasks that tailor LLMs precisely for my work and personal tasks, and share the useful ones with friends. And I increasingly store my personal data as assets, because it kind of makes sense finally to break out of these walled gardens. For example, there's just no feature of a note-taking app that beats having markdown notes as assets that I can process with LLMs in any way I'd like with every other piece of data that I have. I think this could be a second reckoning of the API-first movement of the 2010s that failed to live up to its promise of data portability. Zooming out a bit, AI and LLMs are undoubtedly the coolest thing we've seen in tech in a decade. At Berkeley in 2008, I took a grad course that covered generative language models, and I never thought we'd see them reach these levels. Even in 2016, I was skeptical. Actually, I was even skeptical using the Da Vinci model in 2020. I see Hi as a way of staying close to the metal in this new wave. This time it's not about writing assembly, it's about being able to deeply interact with LLMs without all the application wrappers, UIs, and artificially constrained degrees of freedom. Thinking back to my early experiences with technology, Hi fills in the pre-internet DOS, Norton Commander, QBasic role, or maybe the post-internet WebRing GeoCities phase. It's a way for hackers, and we're all hackers at heart, to play, experiment, be clever, and share tricks with each other. For me personally, playing with LLMs through Hi has given me a much better grasp of their capabilities than using it through any of the productized UIs. So that's all, and happy hacking.